Determine all critical numbers for the function f of x equals sine squared of x minus sine of x. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals sine squared of x minus sine of x. Sine squared of x means sine of x first and then square the result, and then minus sine of x. The function is made up of two terms. Both of them have the sine of x. The domain of the sine of x is all reals. Therefore, the domain of this function will be all reals, or negative infinity to positive infinity. The next thing to do is find the derivative. F prime of x equals, the first term is a power rule. Bring down the power. Leave the inside alone, sine of x, then multiply by the derivative of the inside to complete the chain rule. Derivative of sine is cosine. Minus the second term, derivative of sine is cosine. So the derivative f prime of x equals 2 sine of x times cosine of x minus cosine of x. We will now set the numerator equal to 0, and the denominator, if there is one, also equal to 0. There's a cosine that can factor out, so cosine of x will leave behind 2 sine of x minus 1 equal to 0. Each of these can be set equal to 0 separately. So cosine of x equals 0. And 2 sine of x minus 1 equals 0, which can be simplified by adding 1 to both sides and then dividing both sides by 2. So the sine of x equals 2, 1/2. Starting where the cosine of x equals 0, that occurs at pi over 2, then again at 3 pi over 2, which are pi apart from each other, and then around again to 5 pi over 2, and around again to 7 pi over 2, and every one of these are pi apart from each other. It also happens for negative pi over 2, and negative 3 pi over 2, negative 5 pi over 2. Collectively, x can be written as pi over 2 plus n pi, where n is going to be any integer. And I'll write it here because most likely with the sine of x equal to 1/2, we will also have n being any integer of some sort. Now let's go down to the sine of x equals to 1/2. The sine equals 1/2 in the first quadrant of the unit circle at pi over 6. It also happens in the second quadrant, sine is again positive, at 5 pi over 6. It does not happen in the third or fourth quadrant of the unit circle because sine is negative in those quadrants. But sine repeats itself every 2 pi, so this will be plus 2n pi on each of these. For n being an integer, so it takes care of the periodic nature of sine, which repeats itself every 2 pi. Then we want to check and make sure each of these are in the domain. The domain here is all reals. And pi over 2 plus n pi, or pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi, where n is any integer, are all real numbers, so they are all kept. And there's collectively all of the critical numbers for the function.